Hello everyone, welcome back to CodeMaster. In today's video, we are going to learn, visualize and implement bubble sort in Python. We will cover how bubble sort works, a step-by-step visual example, Python implementation with detailed explanation. By the end of this video, you will understand how bubble sort works and when to use it. So let's get started. Bubble sort is a simple sorting algorithm that repeatedly compares adjacent elements and swaps them if they are in wrong order. It follows a step-by-step swapping process, pushing the largest element to their correct positions in each pass. While bubble sort is easy to understand, it is not the most efficient sorting algorithm for large datasets due to its complexity of order of n square in the worst case. This is the algorithm of bubble sort. First step is to compare adjacent elements, swap if they are in the wrong order, repeat the process for the entire array. Largest element moves to the end in each pass. Repeat until no swaps are needed. Let's take an example array 5, 3, 8, 4, 2 and sort it using bubble sort. This is the step-by-step sorting process. In the first pass, there will be 3 swaps and the array will be 3, 5, 4, 2, 8. In the second pass, there will be 2 swaps. 3, 4, 2, 5, 8 will be the output. In the third and fourth, 1 swap is present. And finally, it will be sorted and the result will be 2, 3, 4, 5 and 8. With each pass, the largest unsorted element moved to its correct position. Now, let's analyze the time complexity. Best case already sorted will be order of n. Worst and average case will be order of n square. Space complexity will be order of 1 if no extra memory is used. Bubble sort is great for learning but not efficient for large datasets because it requires multiple passes even for small lists. Now let's implement bubble sort in Python. Here's the Python code for bubble sort. Let's go through it step by step. In the first step, n equal to length of array. It will find the length of the array. In the second step, for I in range n, the outer loop runs n times to ensure full sorting. In the third step, swap equal to false, tracks whether any swaps happens. In the fourth steps, for j in range n minus I minus 1, inner loop for adjacent comparisons. In step 5, if array of j greater than array of j plus 1, it swaps the elements if they are in the wrong order. In step 6, if not swapped, it is an optimization condition. It stops early if no swaps occurs. This makes the algorithm slightly faster when the list is already sorted. So this is the explanation which I gave for that code. A normal bubble sort always runs in order of n square, while an optimized bubble sort stops early if no swaps occurs, making it faster in some cases. For regular bubble sort, always run order of n square. Optimized bubble sort can run in order of n if the array is already sorted. Here's what we learned today. Bubble sort swaps adjacent elements if they are in wrong order. The largest element bubbles up to its correct position in each pass. The best case is order of n, while the worst case is order of n square. It's a good for learning but not efficient for large datasets. Now that you understand bubble sort, try coding it yourself. In the next video, we will learn about the selection sort. If you found this video helpful, like, share and subscribe for more tutorials. Stay tuned for more coding videos. See you in the next one. Happy coding.